morning, people. Welcome back after the Diwali break. And we'll have to hurry up a few things immediately after that, basically, because there are a few things which are streamlined for y'all. And this includes basically your internal exams. Now, as far as the details of the internal exams, etc., are concerned, will be shared with you all in a couple of days. In most circumstances, it's going to be an MCQ, and it probably would be offline. I'm not very sure about that. I will confirm it with the exam department and let you know about that. Uh, we have been doing. Let me just bring up what we are going to do for the day, and as I said, and you could see in the title itself that we are going to put up this particular thing, and that's the interior of the earth. Now, having said that, let me just adjust a few things. Yeah, so if I do it this way, you have a larger view of the picture as such. And if you are viewing this diagram, I am very sure that you have viewed it a number of times before today as well in your school days, etc., etc. But since it's a part of our syllabus, and uh, being a part of a syllabus at undergraduate level, okay, or university level, let us say, it would obviously be including a few more things. What I understand about school level geography is that it's more about information and knowing about things. At college level, we are supposed to be going into the details, further details of what needs to be understood. What are the processes? What's the physics of it? What's the chemistry of it? We need to identify it accordingly. Is and what makes it more important as such. But yes, and it was identified much in an earlier lecture as well, and I have been posting recordings of last year's sessions also. That we are required to do as far as paper one, semester one is concerned, or paper one is concerned. We are supposed to do the three phases of the Earth's environment, in the sense, the solid, that's the land, and the liquid, that's water, and of course the gaseous, that's the atmosphere, of which in semester one, paper one, we are supposed to be doing the lithosphere, or the solid part of the earth. And if you remember, in an earlier lecture, we also said that this shape of the earth, or the solid part of the earth, is identified as the geoid. What makes up the surface of the earth obviously is with reference to what comes from the interior of the earth as well. And that makes uh, the study of the interior of the earth very interesting and equally important also. All those earthquakes and all those volcanoes and all those, the history of continents moving from one area to the other, makes it so very important to study the interior of the earth. Why is this happening? How is this happening? Has this been happening in the past? Will this happen in the future? What is the future of life on this particular planet? What is the future of human beings on this particular planet? Speaking about human beings, let me tell you that man has not, nobody, in fact, has entered all the way to the center of the earth to study what it is all about. So, all this information, all this knowledge, I would say, that we have with regards the interior of the earth is concerned, is all related to some evidences that we collect from various earth phenomena that take happen. And earthquakes, let me tell you, have helped us in understanding the interior of the earth as such. And here is where the intelligence of man, the size of his brain, etc., lies. That he has that logic to understand the systems around him, making use of technology and trying to study much beyond the scope of his physical vision. I would rather say in that particular way as such. But it's okay, and we credit all these things duly to the intelligence of mankind that he is doing. But actually, how far has man gone? That's a very interesting thing to know. And let me just bring a couple of slides in front of you all. Now, these are images that I have collected from Google, so I would obviously credit these images to their respective sources. But then, what is all this about? Okay, this is how far man has actually studied his environment, and how far has he been able to actually reach out. Okay, um, you would be in a position to say locate points, say A here, okay, where you can see this A, and then you will see this B and C and D and E and F and G, H, I, J, K. So before going to the subject matter, I won't say this is not the subject matter as such, but your content of the syllabus does not include this, because this is something which is significantly man-made, or where man has reached, or his observations as such. We are actually to go into the physical parts of geography. So possibly it could be that this is not a part of it, but then understanding this gives us the scale to which the interior or the center of the earth is at above. Now, if I ask you now, unfortunately, the situation is that you will not be able to answer me or communicate with me, but I believe that you should be able to uh, comment. And as far as these comments are concerned, I would also request you all to start posting your names in the comment box. Whether they come up or no, I'm a bit skeptical about it, but then they should be coming up, and that should be the record of your attendance as well. Say, beyond that, you could also pose me questions with regard to that, just in case you have any queries with whatever we are going to do for the day. And as far as for the day is concerned, again, our lecture is supposed to be scheduled from 10:20 to 11:10. I would be leaving you all a bit early today, 11 o'clock, because I'm conducting this lecture from my residence and I have to attend a few meetings in the college. So I will be rushing to the college immediately after I close my lecture. There have been a few queries regarding what about offline college and so on and so forth. If you ask me, technically, offline colleges have already started. But let me tell you that on a personal scale, what I had told you earlier also, that those who are at a distance from the college, those who would have to take hostels, etc., when you come to college, I would still want you all to hold. I've already answered a query on the WhatsApp group that we are having a scheduled meeting in the afternoon today, and what is the status of offline lectures and how they would be conducted would be discussed in detail, and I would be in a position to inform all that to you after I come back from there. So I would be posting the reports of that for your purpose, and let us see how it turns out. Anyway, coming back to this, say A here, okay, you'll see that this deep here, this is around this line here is 10,000 feet, and this goes a bit deeper than that. So it's around 11,596 feet. This is a canyon, and this is the Spanish words are so very tongue twisters. Cota Huasi Canyon in Peru is the deepest canyon you can see here. Next to that, okay, number B is the deepest cave. Of course, this is the natural cave. And how deep is this particular cave? This deep, this is here. So if I bring it here, this should be somewhere around 7,000. Yes, it is 7,188 feet. It says plus or minus 66 feet here and there. Now, as far as these feats are concerned, many a times we would not be, yes, most of all are known to what feet is, but then we are more familiar with measuring units in meters. So just to equate it, you divide this number by 3. Say, for example, 7,000 feet, this deepest cave in Krubera cave, this is Abkhazia, is concerned, I divided the three. This should be somewhere around 2,000 meters. So this is 2 kilometers deep, I would say. Once you transfer it into meters, it becomes easier to understand it, because we are very well known to using these units in kilometers. So if you follow by feet, yes, great. But if you're not, you can immediately divide it by 3 and transfer it into meters, and you can use these meters to understand the scale at which. uh, See, here is it's this is the deepest lake. This is the Lake Baikal in Russia, and it's the deepest lake in the world. It's a freshwater lake, uh, and it's what, around 5,000 feet deep. So this again should be near to 2 kilometers depth as such. Okay, so these are natural things. Okay, the natural cave and the natural lake, and of course this canyon here. Then we come to an activity which man regularly performs, and that's going to be the mine. Okay, you'll see that this Tuatona gold mine in South Africa. You'll see that man has gone much, 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 much deeper, and in fact deeper than this particular cave here. The depth of this particular mine is 12,795 feet. So easily, it's somewhere around. Three fours are 12, so 4 kilometers deep. This is 4 kilometers. Just imagine how workers could be working in these mines as deep as 4 kilometers all the way down. Then you have, while we have these deep mining, you have open cast mining. And this open cast mining, the deepest open cast mine is in United States, which is around 4,000, so around a kilometer and a couple of hundred meters deep. As such, 1 kilometer deep is going to be significant. Then we come to the deepest rail tunnel. Okay, this tunnel is in Japan, and this is 790 feet. Okay, so this is 790 feet. And all these two buildings in G and H that we are seeing, the Petronas Towers in Malaysia, and of course this is the Burj Al Khalifa in Dubai. Uh, these look so stunted in front of these, and of course these two human scale look huge, and huge look so very tall as such. So the foundation of this particular Petronas stars is 394. You can see this here. Okay, this is 394 feet in depth as such. And it's only when the foundation could be that deep that they could raise these Petronas stars to that particular height. For a significant period, the Petronas stars remained to be the tallest structures. It was only after the Burj Al Khalifa was built that that became the tallest structure, and that's around 2,700 feet. So this should be somewhere around, let me say, 900 meters, short of 1 kilometer by 100 meters. But that is how tall that is. And then we start going deep here. This is I and J and K. What does I and J and K mean to us? Okay, I is the deepest man-made point. Okay, this is an oil well in Sakhalin Islands, that's in Russia. They've gone 40,000 feet deep, 40,000 feet deep here. Okay, and of course, this towards the left now you must be seeing the layers of the earth, and you'll see that it's only the top of this that we are discussing right now. We are going to go into the interior in some time from now, but that's going to be not before we understand the scale, how far has man gone and tried to go, and so on and so forth. So, deepest mine, or rather the deepest oil well, is say the in Russia, the Sakhalin Islands as such. And then the deepest scientific exploration, okay, this one here, okay, is a bit more deeper than that, more say this is 40,230 feet as such. Okay, this was again a borehole which the Russians tried during the Cold War. Okay, the Cold War was not only a war between Russia and America, the USA, in the military sense, but you'll see that in scientific explorations and advancements, they tried to outcompete each other. So this was one of that experiment which happened during that particular time. Deepwater horizon is 35,000 here feet here. Then diving depth of a sperm whale. Okay, this is L. Okay, this L here. Okay, the sperm whale can dive to this particular depth only. Okay, this 0 feet is mean sea level, and this is to which the distance to which a sperm whale can go deep. And what is that depth? Okay, that depth is around 3,900. So it can go down to a kilometer into the deep waters as such. Deepest point underwater, the natural point, is the Mariana Trench, which is 35,000 feet here. Okay, this is somewhere here where the Mariana Trench is going to be here. The M here reads out the Mariana Trench. Deepest solo dive is a bit around that. Okay, they were not able to reach down, but then this is to that particular length, depth, 35,756 feet. Then OPQR. Okay, now let me see if I'm able to locate O here. I'm not able to locate O, peak of Rocky Mountains. I think this should be O here. This is the peak of Rocky Mountains. And then we start going into the interior. P is the Mohoric discontinuity. That's the discontinuity between the crust and the upper mantle. You must be knowing this by retention. We are made to by heart it to such an extent that we tend to remember this even after we have left our schools for several years to come. And then you have the Q part here. This is the Gutenberg discontinuity, which is between the outer core and the mantle. And then you have the Lehman's discontinuity, which is between the outer core and inner core. What is interesting about this is P, Q, and R. While we were just referring to these depths and heights in a few thousands of feet, here you'll see that it is a few hundred thousands. Okay, the Mohoric discontinuity here, which is just a slender covering over the surface, already is around 100,000 feet deep as such. And you go further down, Gutenberg discontinuity, it is 9 million. So it's around 3,000 feet into the kilometers into the interior. And this, in fact, the layman's discontinuity is 16 million. That makes it what, around 5,000 kilometers deep, as at least. And if we travel to the center of the earth, it is around 6,400 kilometers in depth as such. Another view of the same thing happening, okay, you'll see that we'll just identify a few more things. Commercial planes fly at around 35,000 feet. Mount Everest compared to that is 29,000 feet. And you'll see that if I would be in a position to jump 6,000 feet from here, from this point, I could be landing up in a plane which is flying over Mount Everest as such. I don't know how many of you all have uh, uh, enjoyed this aeroplane ride. I, being a geographer, and we are trained to see at objects from an height k in what is called as remote sensing. I do enjoy looking out, and whenever I travel, I see that I get a window seat and I watch out, particularly if it's not the rainy season. If it's rainy season, it's no use. It's all clouds around you. But if it's in the cold season or in the summer season, you'll see that you tend to look. Now, I have been traveling to the Northeast for, I have done it for at least in the last 10 years. I've done this for at least 6 years. I travel there for conference presentations. I've been in Assam, and I've been in Arunachal, and I've been in Shillong as well. I've been to Tripura as well. What I wanted to say is, when you travel to these places, you have two options. You fly from Pune to Kolkata, and from there on up into the northeastern parts. But I take the other route, that's from Pune to Delhi, and from Delhi to it is the Guwahati airport, or it is Dibrugarh airport. Dibrugarh is in Arunachal Pradesh. Why I take that? It's basically the geographer in me. When the flight takes off from Delhi, particularly, and it travels towards these eastern parts as such, you are able to see the Himalayan mountains towards the left side. And if the pilot is someone who has an interest in geography, he will also let you know that, okay, now if you look out of your windows, you would be seeing the peaks of Kanchenjunga and so on and so forth. That's such a magnificent sight to watch these peaks, mountain peaks, white in snow. It's just fantastic, let me tell you. Anyway, compared to Mount Everest, the Matterhorn is just 4,690 feet, 14,000. Sorry. So this is literally half of that. Matterhorn is the uh, tallest peak in the US as such. And then you have these other Burj Khalifa. We have seen this earlier too, 2,723 feet. And these are the heights to which birds normally fly. And then, as far as the depths are concerned, let me just see if I can. Yeah, the Challenger, we spoke about the Challenger mission, which went into the Mariana Trench, 36,000 feet deep as such. Okay, the sperm whale, we have already said, around 1 kilometer it can dive to. Now, this is interesting. The final resting depth of Titanic is around 12,000 feet. So 12,000 feet would make it 4 kilometers. And then you'll see that the Chinese submarine, a China made submarine, can dive up to 16,000 feet, 5 kilometers. And then snailfish with pseudopodia are found, can be found 25,000 feet down. And then, as I said, an unmanned submarine has dived to a depth of around 35,000 feet as well. One more before we go into understanding the interior of the earth. I'm purposely showing you this basically because we need to understand how deep actually we are to study when we say that man has not been able to go beyond a few tens of kilometers into the interior of the earth. Okay, we need to be in a position to imagine actually how deep all these things are. Okay, and thus the full credit to all these scientists who keep on working and studying the interior of the earth and keeping us informed about what is happening as far as the interior of the earth is concerned. Once again, Mount Everest, and this is something that is interesting and important. The death zone. Okay, now death zone is basically the zone beyond which it becomes very difficult for human beings to breathe as far as open oxygen is concerned. And that is why you'll see that most of the climbers to Mount Everest beyond this particular height will carry their oxygen cylinders with them. And that's why summiting Mount Everest without an oxygen cylinder is a feat in itself. And you'll see that it's fantastic credit to those who do that. Of course, it's very risky, and a few mountaineers have lost their lives because they were not able to sustain through the very low percentages of oxygen that you have on this particular height as such. And then these are a few other places. And yeah, something that we had not done earlier is the highest world habitation, okay, La Rinaconda, that's around 16,000 feet. Okay, this is again in Peru. And then this is the height of the clouds, the highest of the clouds, the cirrus clouds, 6 kilometers high. Okay. And then the standard height of skydiving. You see all these clips coming on Facebook as far as skydiving is concerned. 12,000 feet is from where you dive. Okay, and of course, you have to be very timely to open your parachute to land down on the ground in the best physical state. Then this is Mount Fuji in Japan, and you go further down. Ben Nevis is the highest point in England, I would say, Great Britain. And of course, coming back to these very buildings, the famous Burj Al Khalifa, and of course the Shanghai Tower is here, and the Shard. I don't know how many of you all know this, but the Shard is the tallest construction in England, possibly in Europe. That's what Europe's tallest building, the Shard. Yeah. And then we start going down deep, the deepest of the mines as far as open pit is concerned. We spoke about the Tuatona gold mines in South Africa. And then, of course, this height to which this is the Grand Canyon for scale for us. And this is the depth to which whales can go. This is where Titanic is resting presently, and we go further down. We already said snails fish are found dwelling all the way to this depth beyond 25,000 feet. And the borehole, the scientific expedition that I spoke about, the Deepwater Horizon, deepest oil well, and of course the submarine and all the Sakhalin project that I said, and of course the deepest artificial point on Earth, this borehole that the Russians took to around 40,000 feet. So these are a few interesting facts in relation to what happens around us. But it's time that we take a further depth as far as the interior of the Earth is concerned. Before we go into understanding these aspects, let us look into what is the Earth made up of. Something that we have already looked at in our earlier classes. We know that the layers, the Earth is layered, and if we have studied our physics well, these layers are basically based on the density. So the outermost layer will have the least of the density, and as you go to the interior parts, the density is going to be higher and higher and higher, and the center of the earth is going to be the most dense portion of the whole earth as such. And we initially divided this into crust, mantle, and core. We came to know that the core is in fact further divided into two layers. One of them is a solid, the center is solid, and as far as the outer core is concerned, it's liquid. So we started calling them by crust, mantle, and the core divided into two, outer core and inner core. And later on, we will see that the crust further divided into its layers, the mantle divided into further layers, and studies demanded this layering accordingly. Studies of plate tectonics, which again we have in our syllabus. We have the study of earthquakes and volcanoes. All this required study of the interior, and thus this became equally important. So thickness of these respective layers, you'll see that the inner core is here. The inner core here is around 1300 kilometers thick. As compared to that, you'll see that the outer core is nearly double of it, and the mantle is the thickest of all the cores, around 300 kilometers. I'm purposely rounding it up so we have a fair idea now, and then when we repeat it a couple of times, we will see how it is all about. And in comparison to all these layers, outer core, inner core, and the mantle, you'll see that the crust is very, very thin and very, very fragile. It's just 8 to 40 kilometers, and this thickness also varies. Okay, this variation is huge, 8 to 40 for us, and you'll see that it results in a few activities that we are supposed to be understanding further. Then, coming to the structure of the Earth, let us start from here. The atmosphere, which is 480 kilometers thick. This is the thickness of the atmosphere. Now, it's very interesting to note that when we speak about the atmosphere, different people will give you different thicknesses of the atmosphere. It's not a thumb rule that it's 480 kilometers as such. Okay, when we study the structured layer of the atmosphere, normally scientists speak about it to 480 layers, 480 kilometers as such. Others would say that I would prefer it according to the density, and going by the density in the atmosphere, you'll see that within the first 30 kilometers from the surface, we see that 99% of the atmosphere is accommodated. So they say that something beyond that would not be classified as atmosphere. Of course, every scientist has his her own view of understanding the atmosphere, while others say that, well, we need to call all that space as atmosphere, wherein we have even one element of this atmosphere, one atom of this atmosphere at the maximum depth. So, going by that 29,000 kilometers, people have been able to trace elements of the atmosphere all the way into space till around 29,000 kilometers. So there always tends to be a debate whether it should be 30 kilometers, whether it is 480 kilometers, whether it is 29,000 kilometers. But geographers normally prefer 480 because that's how we study the atmosphere, and that's to the length to which we study the atmosphere. So 480 kilometers is what geographers would prefer. Okay, you'll see that then come to the oceans here. And as far as the oceans are concerned, you'll see that it is 4,267 meters, if not miles. I'm not able to make out what this is. And then you'll see the continents here. Okay, this blue shade here is the content, is the are the oceans. Okay, now this is something that we spoke about earlier: the crust, mantle, and the core here. Okay. The crust, the thickness varies, as I said, from 8 kilometers under the ocean. So, under the ocean, this thickness is going to be very narrow. So, it's around 8 kilometers average, and it goes to around 32 kilometers under the continent. So, obviously, if I'm going to add the Himalayas to this is going to be the 9 kilometers of height of the Himalayas. And just like for buildings, you require bases, mountains also require base. So, the base of the Himalayas will add into that. And if I'm going to add that, okay, you'll see that this and the rest of the say the crust below Himalayas would be around would take that length to around 32 kilometers as such. It's made up of granitic and mafic silicate rocks as such. Now, what these are, we'll come to that later. I don't want to confuse you all here. Okay, so the crust, you will see this narrow line here. Okay, it has given us a lot of description because we know a lot about it because we live on this, but it's very, very narrow. I've already made it very clear in my earlier discussion. The mantle starts from here where the crust ends. The mantle starts and runs all the way down to the outer core, outer boundary of the core, outer core as such. It consists mostly of ultramafic silicates, and then you will see that this is the core. It starts here and all the way to the center of the earth, which is at the depth of 6,371 kilometers to be very precise. Okay, so that is what the core is. Of course, we'll go into the details of this once we understand this part of this particular diagram. And I suppose we should be ending at this because by then it would be 11 o'clock and I'll have to close the lecture as such. Now, while we speak about the crust here, this thickness, there is something that comes up, a new term comes up, lithosphere. Now, what is this? Lithosphere is the rigid crust plus some upper part of the mantle. Okay, upper part of the mantle. Okay, so you add these 40 kilometers or 30 kilometers, whatever this could be, another 60, 70 kilometers of the upper mantle to that, you make up a thickness of 100 kilometers. Okay, a slice of 100 kilometers into the surface of the earth is called as the lithosphere. Now, what makes this very important? You must have, those who come from the CBSC board must have studied the plate tectonics. Even SSC board has it in some class. I don't know which, I'm not able to recollect it. But the plate tectonics is basically the continents that move on the surface. And one plate is basically supposed to be 100 kilometers thick, and that makes this depth, this number, very crucial and important, the lithospheric thing. Now, how do these plates move? It is believed that these plates are basically riding on a surface which is neither solid, which is neither liquid. It is in fact plastic, and this is known as the asthenosphere. The asthenosphere starts just beneath the lithosphere and runs till around the next 700 kilometers as such. Okay, so that is going to be the upper second layer of the mantle. Okay, the upper layer is those 70 kilometers of the lithosphere, lower 70 kilometers of the lithosphere, and then you have the asthenosphere on which the lithosphere keeps on moving. This is plastic, partially molten and deforms fluidly, and then you'll see that we go beyond that, and for the next 2,800 kilometers as such. Okay, this ends at 700 kilometers. Sorry, and around 2,900 kilometers. After that, all you have is mantle. Okay, it's also known as the lower mantle. The upper mantle is the asthenosphere, and the lower part of the lithosphere, and so on and so forth. Okay, this is more rigid as compared to the asthenosphere, and that is what separates it out as such. And then you come to the next layer, and that's the outer core. Okay, which is in a liquid phase. The liquid phase is because of the huge amount of pressure that it has here. And it is also said, those who have studied their physics well will know that the magnetic field of the earth and the gravity of the earth is basically because of the core and the arrangement of the inner core being solid and the outer core being liquid as such. It is also believed that as far as the magnetic north and the magnetic south of this planet is concerned, they keep on interchanging positions. I want you all to read further into that and post material on that in our group if it is possible to you all in the day, or else we'll of course take it for discussion tomorrow as well. So that's outer core, and then it's all the way to around 5,155 kilometers towards the center, and then the inner core, because of the huge amount of pressure that you have toward the center of the earth, it's a huge solid, and it runs to a length of around, or a depth of around 6,371 kilometers is the point at which you would find the center of the earth. This is as far as the general structure of the earth is concerned. We need to understand one more thing before we close up for the day, and that is these discontinuities. When I when I move into the interiors, okay, you'll see that moving from one layer to the other, how do I understand? Okay, you'll see that scientists have used seismic waves, earthquake waves, to understand that, and it is using those waves that we understand that, okay, from this point the density seems to be more, and as I go deeper, it's going to be more and more and more. So these discontinuities are basically regions, though they are seen as lines here. Let me tell you that these are going to be thick regions, because we are imagining this to be 6,000 kilometers. Now, if this is 6,000 kilometers, 6,500 kilometers as such, uh, these lines would obviously be some tens of kilometers, 5 kilometers, 10 kilometers as such. So these, though they are drawn as lines here, let me tell you all that these are zones of a few kilometers thick, and these are also called as discontinuities, because a particular density discontinues to be there, and you have a higher density below that, or as you come from the interior towards the outside, you will have the lower density as you come towards the crust from the interior as such. Two of these densities have already been seen earlier, but we'll be repeating all of them once again, one by one. Okay, as far as the crust is concerned, you'll see that the crust further tends to be divided into the upper crust and the lower crust. And the division between them is identified by what is called as the Conrad discontinuity. Conrad, Conrad, Conrad discontinuity as such. Between the crust and the upper mantle, we have already seen Mohoric, nowadays abbreviated as the Mohos discontinuity here. This is the Mohos discontinuity, this between the lower crust and the upper mantle. As I go further into the interior, between the upper mantle and the lower mantle, I have this discontinuity which is called as the Repeti discontinuity. Gutenberg is the discontinuity. It's one major discontinuity between the mantle and the core. And within the cores, you will see that you have one discontinuity which was discovered by Lehman. And that's basically the discontinuity between the outer core and the inner core. This is a general information as far as the interior of the Earth is concerned. We need to go further and go into the chemistry of the interior of the Earth, the physics of the interior of the Earth, the composition of the interior of the Earth on one side, and comparing it to the Earth's crust on the other. But of course, that will be there will be some time before we take it up, because as I already said, that I would be uh, stopping at 11 o'clock. So I'm doing that, and I'll be back. And if you have any queries, you please type your names in the chat box and post them, just in case, to mark your attendance. And if you have any queries, you can post them in the chat box as well. I will give you a couple of moments. If I can answer them immediately, fine. But if not, it would be answered tomorrow. If you are not able to put them here, you can obviously put them up in our WhatsApp group as well. And having said that, let me thank you all for being present on this. Of course, not many are present here. We have around 120 students, only 35 are attending this live. But since this is going to be recorded, this will be available on my YouTube channel in the evening as well. That's all for today. We'll be meeting same time, hopefully for a longer lecture tomorrow. Uh, I'll end the broadcast.